Okay, we're here with the guide sheet number 3 for the moving in circles. We're talking about the centripetal force requirement. First, a couple of quick review ideas. One being that the net force has to be in the same direction as the acceleration. Force and acceleration are directly proportional to each other, and therefore they must be in the same direction. If we look at the motion as we go around the circle here, if we look for the acceleration in vector A, it must be centripetal, which means it must be toward the center. If we look at the velocity at location C, the velocity must be tangential, and since we're moving counterclockwise, it has to touch the circle at one point and be essentially perpendicular to the circle at that point. The velocity vector at section D, again, it has to be tangent, so it's going to be straight up, close as straight up as you can get there. So this is a velocity vector, this is a velocity vector, and the other one is an acceleration vector. Okay, force analysis. For every instance, in order to move in a circle, there must be an inward-seeking, center-seeking force that is known as centripetal. So centripetally, center-seeking. It's not a force of its own. It's not a new force. It's simply going to be come from one of the forces we've already looked at with our want-if list. Weight, applied, normal, tension, friction, possibly springs, any of those other kind of forces that we've already looked at. And again, it must be centripetal, so it must be toward the center. So in number 3 here, we're just looking at which of our want-if forces would be the one that would create the centripetal force. For a planet orbiting the sun, it's the sun's gravity that pulls the planet in the circle. Okay, we swing a bucket over our heads. The bucket is attached to a string, so that's going to be a tension force. Passengers on the cliffhanger amusement park ride. The wall of the ride is what's going to push on them toward the center. That's a normal force. The moon and the earth, we're back to gravity. The Earth's gravitational field reaches out at the moon, and vice versa. A car making a turn along a level roadway, that's going to be the force of friction. It's the friction of your tires that allows you to make the turn. A car is making a turn along a banked exit ramp. Now, here we have the friction from the tires, but we also get the fact that since it's banked, we're going to get some normal force pointing toward the center of the curve. So you can go faster around a banked curve than you can a flat, level surface. That's why NASCAR uses those nice big curves with the big angle that they do. G, in football, halfback leans in and rounds the corner to head up field. Again, that's pretty much going to be the force of friction between their cleats and the ground is what they're going to use to push off and make that change of direction. Roller coaster at the top of the loop. Now, if you're at the top of the loop, think about this, you're up here. The thing pulling you down is actually, at that point, pretty much going to be gravity. Okay. Now, if it's at the bottom of the loop, then the track has to push up on it, so that's going to be a normal force. As clothes spin around inside the cycle, if you think about where they all end up toward the outside of the drum. That's not because they were pushed to the outside, it's because as they spun, they tried to go in a straight line away from the center of the drum, and the thing that kept them from escaping was the normal force. If you look at most washer drums, they actually have holes cut in them, and that's so as the clothes spin, the water can escape through the small holes while the clothes themselves stay inside the drum. Okay, diagram, question 2 on the front side, draw an arrow to indicate the direction of the net force vector at B and E. Label the vectors F for force. So we're going back to this one for B and E, and we're going to label the force vectors. Now, it's centripetal force, center seeking. So it must be toward the center. So it must go from B, it must go toward the center. From E, it must go toward the center. Again, I'm kind of essentially assuming the center is right in about here, the center of the circle. So centripetal means center seeking, not an outward force as most people would think or feel as they move around in the circle. Okay, so that'll end this version. We'll look at the rest of the guide sheet in our next video.